Hello, I'm Will Vienna, and this is today's chemistry podcast. We'll be talking about titration labs today. The first thing we'll talk about is why it's so important. Here's what our chemistry teacher, Ms. Zeckel, has to say about it.
We deal with acids and bases daily. For example, gastric juices, which are in our stomach, is hydrochloric acid. And that acid is a very strong acid. It has to be able to digest the foods that we put in there, like steak and all that good stuff. And if you have too much production of that acid, then you can have some health problems with that. You can have acid reflux, you can have ulcers, and so we have to find medicines to be able to combat that acidity, and so those would be bases, like milk of magnesia, for example, that when ingested neutralize those stomach acids. And acids and bases are in our daily lives, lemon juice and all of our citrus fruits have ascorbic acid, and there's practical uses of this. For example, if you're cooking with fish and the skin of the fish is very slippery, that's because they have basic compounds on them, and if you get the smell of the fish on your hands, then you can squeeze some lemon juice on that and neutralizes the base and takes away that fish smell. So there's all kinds of practical applications for the reactions of acids and bases.
Personal contact with acids and bases can be very detrimental to health, so lab safety is important during this lab. The first step is to wear goggles and an apron at all times and take care when dealing with the chemicals.
When you're pouring the sodium hydroxide, don't get it on your hand because it burns.
Not only is the experiment somewhat dangerous, but it is also difficult to get exactly right. Here it is from one student to another.
Titration is really difficult, and you can mess up really easily.
Definitely something to keep in mind during this experiment. So, let's get started. First, we make the acid by adding 10 milliliters of hydrochloric acid to 50 milliliters of distilled water. Now set up the 50 milliliter burette as shown and rinse it with 0.1 molar sodium hydroxide. Drain it until it's at the 0 milliliter level in the burette. Now turn on the computer and open Experiment 24 under Chemistry with Computers. It's time to start the actual titration process. But before starting, click the Collect button for about 5 to 10 seconds, and then click the Keep button and type 0 for the value. Now to start titrating. Have one person watch the computer while the other person manipulates the burette. Have the person working in the burette add small increments of the sodium hydroxide while the computer watcher looks out for a pH rise of about 0.15 units. At this point, stop titrating and click Keep. Keep adding 0.15 increments until a pH value of 3.5 is reached. Now you're going to have to switch to increments of 1 drop at a time. It is very important to go slowly during this stage and to titrate carefully. It is faster to titrate gradually than to have to start over from the very beginning if you titrate a little too quickly. Once a pH level of 10 has been reached, you may begin titrating in larger increments again. Once a stable pH level has been reached, you're done collecting data. Now print a copy of the graph and the table windows, and you've successfully completed a titration. Congratulations.
That's about it. 4.1 phenolphthalein, yes.